Alrighty, good evening, everybody. We're going to talk about some of solids, liquids, and gases and properties of matter. We're getting into the good stuff, guys. So, I want you to think about something. If I have an object and I break it in half, how does that affect the density of the two pieces of that object? Density is a property of matter, and therefore is not dependent on the amount or state of the matter, but rather what the matter was to begin with. So, for example, when we were determining the density of the unknown solid in the lab 2 days ago, we had one long piece of solid that had been cut into 4 smaller pieces. Now, is the density of each of those pieces any different? And the answer is no. Those pieces are all the same solid, just cut up into smaller or larger pieces. And so the fundamental property of density of that solid does not change, regardless of how big or little it is. Just like the fundamental density of water doesn't change based on how much water we have. Okay? So just something to think about. So the question is, what is matter? Matter is anything that has both a mass and a volume. So I want you to think about something. Solids and liquids have obvious mass and volume, but what about gases? Are gases matter? And so let's think about that for a minute. So a solid and a liquid I can definitely see. I can feel the weight of a solid and a liquid, but sometimes you really can't feel the weight of a gas. And you can see physically how much room or how much volume a solid and especially a liquid takes up. But can you ever, sometimes you can't even see a gas. A lot of the times they're clear or colorless. But the fact remains that just because gases have a very small mass doesn't mean they don't have any mass. Gases do weigh an amount. It's just often difficult to see or to detect because it is very small. Gases also tend to have very large volumes, and sometimes they are so large that we cannot see the end of them and therefore often forget that there really is a volume there. So like the volume of carbon dioxide in this room, the carbon dioxide is taking up every space in this room. And so it's really hard to see how much is there because it's hard to determine it because you can't see it, number one, and it takes up so much of everything that you tend to forget about it. But gases most definitely are matter. They do have both a mass and a volume. So that was just something for you guys to think about and to kind of contemplate. So what are the states of matter? Matter can be found in 3 different forms or states of matter. We have solid, where the molecules are tightly packed next to each other and it is very dense and it doesn't move around a lot. The vibrations at the molecular level don't cause a lot of movement from these tightly packed molecules. And we'll be getting more into this later when we talk about molecules and atoms. But that's what a solid is. We also have liquids. And liquids also have molecules, but these molecules are more free flowing. They're able to move past each other. They're brushing past each other as they're kind of moving around. Liquids can flow. Solids cannot flow. We also have gases, where we have small molecules or atoms that are very bouncing off each other. They're very energetic. They move around a lot and they take up a large volume. They are hardly ever tightly packed. There's a lot of space in between the molecules. Now, solids, liquids, and gases oftentimes, or not oftentimes, always have different energies associated with them. It takes energy to keep these atoms tightly packed, but it also takes a lot of energy to get them to start moving. You have to apply energy or usually heat into a substance in order to get it to go from a solid or to a liquid state. In order to get those molecules moving faster, you have to apply heat to them or energy in the form of heat. And then to get them into a gaseous form, you have to apply even more energy in the form of heat to get them to start moving much, much faster. So then what defines matter? Matter can be defined by 2 distinct properties: the composition of the matter and the properties of the matter. And what I mean by this is that the composition of matter is what the matter is made up of. For example, water is made up of atoms of hydrogen and oxygen. Whereas the properties of matter are what distinguishing qualities are associated with the matter. There can be two types of properties, physical and chemical properties. For example, water has a chemical property of being very conductive, meaning that electricity can go through it and flow through it, which is why you don't want to stand in water in a thunderstorm, because you could get electrocuted. And it also has a physical property of having a high surface tension. This means that the droplets of water or molecules of water want to stick together. And this is why rain falls as a drop, and why you can see bubbles of water clinging to the surface of your shower in the morning. It's because of the surface tension that's able to form those 3D bubbles and not just be a sheen of liquid on the surface. Excuse me. Physical and chemical changes of matter. So matter not only has physical and chemical properties, but it also has physical and chemical changes. A physical change is a change that occurs to the appearance of the matter, but not to its inherent, or what we talked about, compositional properties. So that's what a physical change is. Whereas a chemical change is a change that occurs to the inherent, or compositional, again, properties of matter, making it become a different type or piece of matter. So the physical does not change the composition. The chemical does change its composition. Those are the two different types of changes, physical and chemical. So here are some examples of physical changes. Some examples of physical changes could be water changing from liquid water into solid ice. So ice has the same compositional properties as water does. They're both made out of hydrogen and oxygen. It's just whether or not those molecules are tightly packed or free flowing. So it's a physical property of those molecules, not an actual change to the molecules. Or a piece of wood being cut up into smaller pieces of wood. Again, the wood is still wood, it's just changed its size. It's one of its physical properties. Water changing from liquid water to gaseous water. So this is kind of the further extension of liquid into solid ice is liquid water into gaseous water. Steam isn't actually any different from water. It's still hydrogen and oxygen. It's actually what we call gaseous water. So when you're boiling water, those bubbles in the water are not bubbles of hydrogen and bubbles of oxygen. They're actually bubbles of gaseous water or steam. Crushing or grinding flour is also a good physical change. We're not changing the flour's chemical properties. We're not changing its inherent or compositional properties. We're just changing its texture. Or a piece of paper being dyed purple. The piece of paper is still a piece of paper. It just has a different color. So that last one is kind of tricky because a color change is not always just a physical change. Sometimes a color change actually is a chemical change, but it's more dependent on how that change occurred, whether it was a reaction or just a physical property. So some example of chemical changes. Water, H2O, becoming hydrogen peroxide, H2O2, through a chemical reaction. So now our water is actually becoming something else on its composition, on a compositional level. Water is no longer just H2O, it's now H2O2. And so that's no longer water, that is something else. Something happened to the composition of water to change it. When you burn a match, when a match burns, it changes its composition. It undergoes a chemical reaction and is no longer the same piece. It's no longer the same match that it was. It has different elements and properties and chemical properties to it. The same goes for wood burning in a fireplace. The wood is physically changing what it is chemically, not just getting smaller like a physical change. It's actually changing what it is. Food being digested in your stomach, it doesn't just get smaller like a physical change. It actually becomes something different. And a metal dissolving in acid. The metal isn't just becoming smaller, it's actually breaking apart and it's no longer the same metal, it is something different. And the acid changes too, because now it has different properties in it. So those are just a brief overview of some of the chemical and physical changes that we'll experience in chemistry and some of the chemical and physical properties of matter, and just a kind of a brief overview of solids, liquids, and gases. You guys should know this stuff. But we're going to be getting into properties of matter here with density, what we've been talking about, And we're going to get into something called specific heat soon, which is a property of matter. So you guys have a good weekend. Thanks for listening.